Okay, this is the second example. I'm trying to tie a couple of concepts together. And basically we've got an object at the center being acted on by a couple of different concurrent forces. So we've got one of the forces 4 newtons, another one's 1 newton, the other one's 2 newtons. Now I could simply in this situation say, look, this 2 newton force is acting in the complete opposite direction to that 4 newton force, and say, well, overall it'd just be 2 newtons in this way and I wouldn't have to worry about that force. Okay, that simplifies the situation a lot. I'm not going to approach it in that way this time, because I'm trying to show you a method that would work for a situation where it's not like that, okay, where it's not completely opposite. Okay, so what we're going to do is break it up into the I and J components. So I'll break this first 4 newtons in that direction up into 2 components, this one here and that one there. Now to do that, I need to know the angle between the nearest x-axis and that 4 newtons, which is going to be 60 degrees because that is 90 degrees there. Okay? And therefore this force here is going to be equal to -4, because it's in the negative direction, -4, and that's 4 newtons for the hypotenuse, cos of 60. Okay? And up this way, I'll end up with +4, because we're moving in the positive direction, sine of 60. Okay? So if I'm looking for this resultant force acted upon this body or this object at the center of these 3 forces, then the first force of 4 newtons can be broken up into the I and J components of -4 cos of 60 degrees I plus 4 sine of 60 degrees, and that's J. Okay? Now moving to my next force, the 1 newton force. And it can be broken up into this force here plus that force there. Okay, so it'll end up being plus cos of 60 degrees I plus sine of 60 degrees J. Okay? Because that's the sine of 60 degrees. This is cos of 60 degrees. It's just 1 newton, so that's why it's just 1 times by that. Then my last force, this 2 newtons going this way. Well, I really need to work out the angle between the nearest x-axis and that force there. Okay? Now I know this one here is 30 degrees, so vertically opposite angle is 30 degrees there. And because that's 30 degrees and this is 90 degrees, that must be equal to 60 degrees there. Okay? So if I include that, I'll end up with 2 times by cos of 60 degrees, because that's that component. Okay? And that's my I, and then I'm taking away, because this is negative, okay, it's going in a negative direction, so I've got that plus that, it's going to be take away 2 sine of 60 degrees, and that's in J direction. Now, just so I didn't have a calculator, I'm going to use the exact value triangles to try and sort this problem out. Alright, now if I have 60 degrees here, 30 here, opposite the 30 degree angle is the 1, opposite 60 is square root of 3, and opposite the 90 is the 2. I can work out each one of these. All right, so I'll end up with -4 times by cos of 60. Cos of 60 is equal to adjacent over hypotenuse. So we end up with a half times, that's my I component, plus 4 times sine of 60. So it's opposite over hypotenuse, so it's 4 times the square root of 3 on 2. That's my J component there. And I've worked out the rest. Luckily for me, they're all the same. So it's going to be another half I plus square root of 3 on 2J plus 2 times cos of 60, which is a half I, take away 2 times square root of 3 on 2. That's a J component. Now I'm just going to add the I and J components together, so I end up with -4 times by a half, which is the same as -2, plus a half, okay, plus my last component, 2 times a half, it's just 1. That is going to be my I component. Then to that, I'm going to add all the J components together. So 4 times square root of 3 on 2 is the same as 2 square root of 3. And then the next one, which is plus square root of 3 on 2. And then the last one, which is take away. Well, 2 times square root of 3 on 2 is the same as just take away square root of 3. Okay, and that is my J component. Now from here, if I simplify this, -2 plus a half plus 1 is the same as a -half. Okay, and the j component, well, I've got two of these square root of 3's. If I take away one of them, and then I take away another half of them, okay, then all I end up with is square root of 3 on 2. Oh, hang on, sorry. 2 square root of 3 plus the square root of 3 on 2. If we take away, we get 1 square root of 3, so we've got 1 and a half of them, sorry. Because there's 2 of them. If I take away 1, we've only got 1 square root of 3, and we add another half, okay, we've got 3 on 2. It's the same as 1 and a half of these square root of 3's. That's j. Okay, now if I want to know the magnitude of this force, I really need to look at squaring each one of these and square rooting, okay? Because I don't want the I and j components anymore. I want the resultant force, and I should be looking at the angle as well. Okay, so if I want the magnitude of this resultant force, it's equal to a negative a half squared plus 3 square root of 3 on 2. That's all squared as well, all square rooted to give me the magnitude of that force. Okay, and if I do that, squaring that is going to be a quarter. Squaring this is going to give me 9 times by 3 divided by 4. Okay, and all square root. Okay, and then when I do that, I'll end up with 9 times 3 is 27, 28 on 4. And if I simplify 28 on 4, I'll end up with 7. So I have a magnitude of this force of 7. Okay? So my resultant force is square root of 7. Okay?